Hello, welcome to the Advanced Fuel Cycle presentations. My name is Frank Goldner. I'm the headquarters program manager for accident tolerant fuels, but I have my other colleagues here with me, Jeanette Edens and Ken Keller, and I think we have 5 very interesting proposals for you to consider. So please listen to them, and we'll start by Janelle giving them some background.
Okay, sure. So good afternoon, everyone. Like Frank mentioned, I'm Janelle Edens, the program manager for the Advanced Reactor Fuels program. And we just wanted to give you a brief overview of the Advanced Fuels campaign before we went into the work scope topics. So this slide gives a very brief overview of the Advanced Fuels campaign. We have 2 main missions or programs that we support. We have the Accident Tolerant Fuels program, where we're working with 3 U.S. vendors, GE, Westinghouse, and Framatome, to develop LWR fuels with improved performance and enhanced accident tolerance. We also have the Advanced Reactor Fuels program, which is currently focused on fast reactor fuels. And in this program, we're developing both transmutation fuels for longer-term missions and more near-term fuels for once-through fuel cycle. Then we have Ken's area, the capability development area, and this includes treat testing, separate effects testing, and PIE techniques. We finally have the fuel product line, the Moose, Spice, and Marmot Fuel Performance Code, which we work closely with the NEAMS program to develop. So this next slide lists our 2019 NEAP awards. There were 6 awards in 4 areas. And we encourage you to take a look at this list because the work scopes for this year are similar to some of the work scopes for last year. So we just want you to take a look to ensure that you're not proposing anything that's duplicative from what was awarded last year. And with that, we'll turn it to Frank.
Okay, thank you. Is Tarak, are you on the line? Okay, well, this is the first one called Non-Destructive Examination Techniques for Assessing Integrity of Coated Cladding Tubes. This is pretty narrow focused, and Tarak Saleh will talk to you about it. And the important thing is to listen very carefully, because a key of this is that you have to find a direct, useful application with one of the accident-tolerant fuel vendors. Now I'll turn it over to Tarek.
Okay, great. Can you hear me okay, Frank?
Yes, we can.
Okay, great. Thank you. So, right, as Frank said, this is for non-destructive evaluation of the integrity of the coating on cladding tubes as part of the accident-tolerant fuel concept. The vendors that we're working with through DOE are typically working on thin coatings, somewhere on the order of 2 to 20 microns in thickness, usually either on zirconium alloy tubes or 6-thick composite tubes. And what we're looking for on this call is to verify the thickness and uniformity of the coating layers, identify where coating may be missing, and confirming the quality of the coating and the substrate bond. And this is all non-destructive evaluation of as manufactured tubes. If you could go to the next slide, please. Am I in control of this? There you go. Thank you. So, like I said, this is for innovative, non-destructive, and hopefully high throughput inspection techniques for the coatings on zirconium alloys or thick composite tubes. As Frank mentioned, we want the applicants to work closely with one of the DOE ATF vendors, so Westinghouse, General Electric, or Framatome, in order to obtain coated cladding for testing. The application should clearly indicate which coating cladding combination is being investigated and where the coated cladding is coming from. And if there are IP issues, we expect the applicant to work directly with the fuel vendor to clarify that, as some of these coatings and the method of the coating application are in the protected intellectual property regime. So to be clear, no portion of the funds from this can be used to develop new coating technologies. And again, this is for as manufactured, as fabricated coating tubing. So this is not for post-irradiation. So just as manufactured. And again, looking for high throughput techniques is the ultimate goal. So we want to develop a useful inspection technique to support commercial concepts involved in our accident tolerant fuel program. So it's a fairly clear, as manufactured, working closely with industry inspection of coated cladding tubes. And I think I can take any questions if there are any.
So we are going to hold questions until the end of all 5 presentations. So
Fair enough.
we will.
Just want to add one more thing. Some of you may remember that last year we had a call for coding measurements, but that could be used inside of a hot cell and the information transfer. That's a post-irradiation situation. This is not anything to do with that. Some of the techniques may have some relevance, but this is really during manufacturing quality control assistance. That's why I just wanted to add that one, and then we'll move on to the next.
Okay. So now we move on to FC 2.2, investigations of carbide and nitride fuel systems for advanced fast reactors. And I am the Fed manager for this work scope, and Andy Nelson from Oak Ridge is a technical point of contact. And this is very similar to the work scope that we had last year, but this year we chose to focus exclusively on nitride and carbide fuels. And one of the reasons for that is that U-Zirc and MOX fuel have been extensively studied. We have a lot of historical information on those fuel types. But with the UC and UN fuels, we have a lot less data. So the purpose of this call is to address challenges of UC and UN fuels by leveraging modern experimental and modeling tools. So priority will be given to proposals that include both experimental and modeling activities. We'll also give priority to proposals that address high priority items that have been identified for these fuel types, such as chemical compatibility, as well as fuel property measurements to fill gaps in existing databases. And there's a more complete list of priority items that I will discuss on the next slide. So this slide discusses the industry needs for fast reactor fuel development. We held a GAIN workshop in March of this year, and we had the fuel vendors come in and discuss with us their needs for the fuel development. And the third bullet on this slide goes through what the needs were identified for the UC and the UN fuels. So we recognize that not all of these items would be appropriate for a university, which is why we provided the short list on the previous slide, which we thought would be more appropriate for university work. But if you think your university can address any of these topics, then we welcome you to propose those activities. So this slide gives a bit more detail on exactly what we're looking for. Like I said before, we're only looking for proposals that address UC and UN fuel for fast reactor applications. We're only interested in solid fuel concepts for previously defined fast reactors. And in terms of irradiation, because of timing, budget, access, we don't expect that you will propose any neutron irradiation activities. We also request that you don't propose any ion beam irradiation activities. So for this call, we consider irradiation to be outside the scope of the call. And with that, I'll turn it over to Ken.
Hello, I'm Ken Keller, here to talk about 3 calls that we have in the area of experiment capabilities. First is accelerated fuel testing, FAST, which stands for Fission Accelerated Steady State Testing. This is an idea we're pretty excited about. It's generally, the concept was developed to basically test fast prototypic fuels. As you know, we lack the environment, a fast neutron environment, so we historically have been shielding a lot of our thermal neutron flux, and by going to miniature fuel, we can get prototypic peak centerline temperatures, temperature profiles, and high burnup rates. And also, a fast fuel has a fission fission rate that's fairly flat across the pin, and with the narrow diameter, the dimensions of the fuel more directly approach the mean free path of the neutrons. So what we're looking for in this call is PIE capabilities. We're expecting to have a large number of these mini rodlet fuel samples, and this fast approach is unique to generally a rodlet shape. Think a clad fuel element, but miniature. Since we're going to have a very large number of these, there's a couple challenges. One, having a large number of samples that you have to handle in a hot cell. So just industrial systems engineering type approaches might be needed to handle and analyze the fuel pins. Also, the small size of the fuel pins may introduce unique challenges to conducting PIE. So in this call, that's what we're interested in. The technical point of contact is Luca Capriotti. I'm the federal director. And let's see. So again, the purpose of this call is to solicit proposals to develop and demonstrate innovative techniques that can be applied in a hot cell environment. And your applicants are expected to demonstrate your capability using unirradiated surrogate specimens. So your proposal has to involve physical work and physically demonstrating success, not just doing a paperwork exercise. And also we're not limiting to non-destructive. We're also looking at destructive techniques where you could develop a method where you open up the pin for investigation. And examples of measurements include some examples: cladding deformation, fuel swelling, fission gas release, which is expected to be different and might be more challenging than doing full-scale pins, microstructural characterization of fuel or cladding. So that's generally it for FC 2.3. FC 2.4 is maintaining and building upon the Halden legacy of in situ diagnostics. You may be aware that a lot of fuel testing was done at the Halden reactor, and they had some various unique diagnostics, a lot of them using LVDTs. What this call is looking for is work to replace those capabilities. You don't have to mimic what Halden did. You're unconstrained by the technologies you use. It's the capabilities that we're looking for. What this slide shows is one thing Halden was noted for. They could take an irradiated full-size fuel assembly and create small samples while preserving the properties of the fuel. For example, a ceramic fuel that's cracked, they have a method where they would infuse CO2 and freeze the fuel pellets in place, so you can then cut, polish, drill, insert thermocouples and such. Now, we're not looking at you to work on this repackaging and rodlet preparation. I just want to point this out so that there will be an opportunity to have access to the interior of fuel in some cases. So when you're considering your diagnostics, consider that you might actually have direct access to the fuel as it's being reformed into rodlets. One notable capability of Halden was to put multiple diagnostics into one test specimen, and that's all this graphic shows. It just shows there's multiple diagnostics in a very small area. So that's another area we're interested in, is miniaturization and co-location of multiple diagnostics. Real-time diagnostics can be very important. For example, the graphic to the right is a pretty creative scissor type crack propagation setup where you're irradiating a sample in the core, and you have a pneumatic system and a bellows where you can actually apply a pressure and apply a certain stress to a crack, and then have sensors that actually real-time see the crack propagate. So very excited about real-time measurements. Some of the areas we're interested in are creep, crack propagation, swelling, corrosion and crud buildup, temperature, pressure, flux, two-phase flow characterization, and fission product transport. Research that enables in-core application and associated logistics is also encouraged. We're very interested in, like I said, miniaturization, non-contact, non-intrusive, as well as innovative data transmission techniques. And we've seen some people are thinking about wireless methods. That's also encouraged. And when I say wireless, it's not essential to have wireless be received outside of the reactor. If you can just have a wireless signal of any kind that crosses, say, a safety barrier, you know, the containment barrier. We're talking just millimeters or at most centimeters. That is very interesting for our experiment capability and replacing what we lost when we lost Halden. FC 2.5. This is a NEUP, NSUF offering. We offered, it's very similar to what we offered last year. It's up to 3 years, 500,000, and must include an access request. Dan Walks is the technical point of contact on that. So what we're really interested in is microscale material science, thermomechanical engineering, and we're especially interested if it's linked to advanced modeling and simulation techniques. So we're really interested in developing physical models that can help advance codes. So what we're looking here is treat it can have a really rapid turnaround for experiments in conjunction with the IMCL, the Irradiated Materials Characterization Laboratory, and using the March capsule. We anticipate the researchers, I'm pretty excited about this. I would think a lot of universities would. You get to do the full spectrum here. You get to design an experiment, assemble the experiment, field it in a reactor, irradiate it, withdraw it, and do PIE. And hopefully, like we said, help develop models. And also, it's not just model development. We also are open to integral tests that would confirm models. You know, you would run your models, predict the outcomes of an integral test, and then run an integral test. The proposals are sought that will leverage TREAT's minimal activation reusable capsule holder called March. It's pretty simple containment. We can have dry or wet. I think we show that on the next. Yeah, there's March Seth, which is dry, and March Certa, which is liquid. Examples include in situ evaluation of physical properties of fissile material while under radiation, thermomechanical responses, and short-term microstructural evolution. Keep in mind, TREAT is a short-term reactor. You should be thinking pulses or very short duration reactors, and we expect TREAT and IMCL to be both included in your nuclear facility access for your NSUF application. And we did offer this first year 2019, and you're highly encouraged to review those proposals. One, get lessons learned from how the last year's awards are progressing and what they're learning, and also to ensure that the work you propose is complementary and not repetitive. And that's it for all our 5 presentations. So now we're open to questions on all 5 calls.
Thanks, Ken. We will open the lines to the National Technical Director, Steve Hayes, at the Idaho National Laboratory, and the TPOCs that are available today. When you do address questions for these scopes, please put the work scope identifier or some identifying feature so that we can direct those questions to the correct people. Steve, we've just unmuted you. Are you available?
Yes, can you hear me?
Yes, we can. Tariq, are you still there?
I am.
And Andy Nelson, are you there?
Yes, can you hear me?
Yes, we can. Okay, we will get our federal points of contact out in front of the podium, and we'll get started on questions. For FC 2.3, the scope talks about exploring a diverse set of fuel design parameters. Can you get a list of the fuel design parameters that are of interest? Or excuse me, can we get a list of fuel design parameters that are of interest?
Thank you.
Go to Steve.
Steve, I'll defer to you.
Or Andy, if he wants to say something. We can certainly generate a list, but I mean, they're the classical fuel performance parameters, you know, properties, especially. Andy, did you want to say something more?
So was this me or was this Luca's category?
Oh,
Yeah,
I
this is
was.
Lucas.
It's Lucas.
So this is the PIE?
Yes.
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 Oh, okay. So, well, the big ones are already listed. Cladding deformation, fuel swelling, fuel axial growth is part of that. Gas release of any kind that may be part of it. Microstructural characterization of the fuel or cladding, any sort of microstructural features that can be measured quantitatively, grain size, porosity, things like that are of interest. Those are the big ones. There could be other things that we could think about.
And one thing that comes to mind is just imagine, I'm thinking, imagine someone at a hot cell with their manipulators trying to handle 20 of these things. Just think of the human factors involved with the challenges of doing whatever, X-ray tomography or whatever it is you're doing. There could be opportunities for just a basic mechanical engineering improvement of the process.
Moving back to slide 4 for NDE testing. Are these coatings metallic?
Yes, they're not all metallic, but most of them are metallic, chromium, for example, but there also is an advanced one from General Electric that's more in the ceramic area. But basically, the other two vendors are chromium type.
Is the difference in scope for FC 2.1 this year compared to FY 2019 only that it does not need to be integrated into a hot cell?
No, it's more than just that. The last year's one was a post-irradiation focused item for a hot cell. This is something the vendors could use as a qualifier of what they're fabricating. So this is clearly a difference, and it's unirradiated and post-fabrication. Steve?
And Frank, I'll add that it's, yeah, high throughput is the ultimate goal. So as fabricated, full inspection, non-destructive is the goal on this.
That's a good point.
So
Not sure where this is directed, but is the coating only on OD?
Yes, it's basically a coating on a Zerk cladding.
As a follow-on to that question, do we have access to both ID and OD of the tube?
I think that's something you'll have to discuss when you contact the vendors. If you need it for your technique, I imagine they could make something available, but that's something to be discussed.
On slide 10 for FC 2.3, what are the exact materials to be tested?
It's a fuel, it's a wide range of any fuel. The idea is we're taking any rod shaped fuel and miniaturizing it so we can do accelerated testing. This could be Zerk, silicon carbide. It could be fast fuels, metallic fuel, ceramic fuel, fast spectrum, thermal spectrum. It's pretty much limited by just the shape, the cylindrical shape, because you have to get the cylinder in there, get the gas gap, get the sodium bonding to get the right thermal spectrum, and then get the linear heat generation right. So the sky's the limit as long as it's a rod.
But if I could add that for the purposes of this call, we expect demonstration on surrogate specimens. So we don't expect you to do any irradiated fuel type specimens.
Yes, sure.
In FC 2.1, Does the NDE technique need to be portable or be able to survey the entire length of the fuel cladding?
I don't know if there's a requirement for portability. That's again something for you to discuss with your partner. But it's important that and I think the right word was said earlier by a gentleman, is can this help them qualify what they're doing faster than what they might have considered in the past?
Yeah, so this is Hayes jumping in. Frank is exactly right on this. This was an area that was actually proposed in principle by the vendors or the industry. So they are looking for a technique that would be installed in their fabrication plant. So I don't think portability is an issue at all. But in relative to inspecting the full length of the coated area, yeah. That's exactly what would be needed.
For FC 2.1, what is the smallest expected flaw size that the NDE technique must be able to detect?
Again, my answer to that is find out what the vendors think they can do right now and whether they want, how they want to improve on it.
For FC 2.2, the GAIN workshop identified several industry needs, most of which involve irradiation effects, but the FOA specifically states that irradiation effects are outside the scope. So is there another specific need that DOE is targeting to fill/understand with this call?
Yes, so like we discussed on slide 6, there are 3 areas that we think would be appropriate to be done at a university. Chemical compatibility with between the UN fuel and the lead coolant, compatibility with the steels or the aluminum forming steels, as well as fuel property measurements to fill gaps in existing databases. So there are additional areas outside of irradiation.
For FC 2.2, are high throughput measurements of microscopic thermophysical properties and how to use them? Hang on, let me reword this question.
That's only like 2.3.
For FC 2.2, are high throughput measurements of microscopic thermophysical properties to predict bulk properties of interest?
I guess I'll defer to Andy on that.
Sorry, could you repeat the question? Is this for 2.2 or 2.3?
Sounded like it was for
It's directed towards 2.2. And the question is, are high
Sounds
throughput
like it's for
measurements? Go ahead, Steve.
Sounds like it's for 2.3.
It may be for 2.3.
Or 2.1 maybe, I'm not sure.
Yeah, can you repeat the question?
Yeah, the question is,
Yeah.
are high throughput measurements of microscopic thermophysical properties to predict bulk properties of interest?
Go ahead.
If you're talking 2.
Well, if this falls under 2.3, a hot cell technique.
If that's the case, high throughput is of interest because we expect to have a large number of samples. So yes, decreasing the time of any kind of analysis is of interest. If you're talking for the micro rodlets or the mini rodlets. Steve, chime in if you want.
No, I agree totally. That's the right answer.
Is there a good place where material modeling can fit in FC 2.3?
Absolutely. The PIE is supposed to confirm or inform material modeling. Sorry, Steve, I cut off your
Yes. Yes.
That's okay.
Okay.
Steve, do you want to add anything before we move on?
I would say Ken is correct. There are some, this needs to mate up with advanced modeling and simulation activities in the area of fuel performance. That being said, the call is really about experimental techniques for these specific type of samples. I don't think we would be looking for a proposal that was just modeling. That would not address the call.
Oh yeah, I hope all I meant, yeah, I hope to double down to now back up Steve. Yeah, we're just looking at PIE techniques. All I meant to say is every PIE technique should ultimately yield data that will either confirm the results of a model or inform the modelers. Yes, we limit this to PIE techniques.
That's right.
On FC 2.4, does it need to be compatible with treat or ATR?
Well, to be fair, the most of what Halden did was steady state and power ramping. So we're mostly interested in ATR, but we're open to treat applications too. But the focus should be the steady state irradiation diagnostics that was conducted in Halden.
For FC 2.5 treat testing, what fuels are you interested in? Is uranium silicide of interest?
Since we're talking separate effects testing, I'm uncomfortable saying what fuels we're interested in. I like to see things generally at smaller levels. Of course, integral tests, it should be a fuel that is of high interest, high programmatic interest. But really the main thing is separate effects testing. So that's kind of at the sub-fuel level.
Well, I would say that silicide is a fuel of interest, so that's not ruled out.
Right.
For FC 2.2, will you support the development of new, innovative, and economic preparation methods for UC or UN?
Andy, what do you think? I think we would, but I'll let Andy weigh in on that.
Yeah, I think that, I mean, that's certainly an area where there could be some innovative work done. You know, the big issue for this call, you know, is convincing the reviewers that the problem you're looking at is a high priority one. You know, there's many different things that you can look at for UC or UN, and you know the different problems that are outlined on the slide. So, you know, making the case that fabrication is truly one of the big factors impeding deployment and advancement of either of these fuels. If you can do that and then propose a better way than the reference techniques that are available, that could be tractable in my view.
For FC 2.1, will the ATF vendor be a collaborator on the proposal?
Well, they know about this, and they would have to be interested, or it wouldn't be welcome. So you know, they know about we're doing this. As Steve mentioned earlier, we're doing it as a result of an industry representative group telling us this is of interest.
For FC 2.1, does NDE include only non-contacting methods? What about contacting methods with very minimal effects?
I mean, that doesn't sound unreasonable to me.
Also for FC 2.1, are you looking for post-process NDE techniques to evaluate coding or techniques that could be used during processing, or both?
I'm not sure. If post-processing means after it's been fabricated, that's clear to me. Whether it would be useful while it's under fabrication, again, I would forward that question to the vendors of what they're interested in. It might be useful, you know, but my initial assumption, as I understood this, was post-fabrication and pre-use.
That's right. In my discussions with the industry folks in this area, what they're looking for is a final inspection of the as fabricated coated tube. So they're not looking for process monitoring, although Frank is right. I mean, they could talk to the vendors about whether or not that's really of interest. But what this call was written to address was a final inspection of the as coated tubing to determine whether or not it meets specification.
For FC 2.1, can you identify methods used by other industries that aren't applicable for this application, or reasons why they might not work?
That sounds interesting. Doesn't sound wrong to me. But again, the main thing is to propose it, or at least check in with the vendors. If I understand it, you're saying if there's some method that's been developed elsewhere, for, let's say, fuel cladding, and you think it might be applicable, that could be interesting.
For FC 2.1, what are the typical inner diameter, outer diameter, and length of the test tube?
This is again a repeat of what we've heard earlier. I think that's again the type of thing you want to check with the vendors. Obviously, if it's post fabrication, you know the length of a typical LWR assembly pin, and inner and outer dimensions. I can understand why you need that information for some techniques, but again, run that by the vendors.
The cladding dimensions are not a secret. I mean, they're publicly available. PWR, BWR cladding tube diameters. Now, each vendor will have the thickness of the coating they're trying to apply will be vendor specific, but the tubing is just what is in common commercial use.
For FC 2.2, the chemical interactions could be an issue for MSRs, but not GFRs. The uncertainties of UC and UN are in their irradiation properties. Why aren't you recommending irradiation in PIE?
So we don't think that with the 3-year time frame and the 800K maximum that you will be able to do neutron irradiation, and we believe that ion irradiation for fuel is less useful than neutron irradiation would be. So we're keeping irradiation outside of the scope of the call.
Is fee crawl being considered under FC 2.3?
Yes, yes. But I'm unaware of the manufacturing challenges of making feed crawl at that small of a dimension.
For FC 2.1, what is the expected scan speed of the testing?
Well, again, that requires the vendor's requirements. I think the word rapid assumes that it's not going to be an overly long time. Remember, you know how many pins are in an assembly. There's a huge amount. So clearly, I think speed is going to be a selling point on whether this is interesting to the vendors.
For FC 2.2, are you considering fuel surrogates for these studies?
Well, we specify UC and UN fuel, so if you could find something that behaves like they do, then sure, but we're really interested in the UC and the UN applications.
For FC 2.1, do you have contact information for the vendors so we can get in touch to devise a plan or to discuss proposals?
Well, we've listed the 3 names there. And by the way, I was going to say later on, at the end of this presentation is a list of our contact information. So if you don't know who's already the right people, we have the contact information. We'd be pleased to give it to you. Just send one of us an email.
For FC 2.3, do you need to demonstrate the testing methodologies in a hot cell environment?
No. But expect you to work closely with the technical point of contact so that you're aware of the realities of the hot cell environment, so you don't create some giant truck of a thing and be surprised why you don't get accepted.
How many awards are expected under FC 2.1?
Look, we try to evaluate everything. You know what happened last year. There was some limited amount of what we can do. A lot hinges on the funding that will be given to NE to cover these. You know, all the programs contribute. And last year, some money had to be needed for some other efforts and all. So my feeling is that it's probably it's going to be limited again, and hopefully it won't be as limited as last year. But that's why it's so important to have somebody on board that it's easy for us when we do a relevance review to understand, or whoever other than the final reviewers. So I would like to say that the value of the proposal is more important than the number, but the reality is, you know, we have 5 areas. They're all interesting. Last year, we were lucky to have 1 or 2 in each one of them. So that gives you an idea. It was tight last year. We hope for a better freedom this year.
Okay, thank you to everyone that participated in this session. Andy, Steve, Tariq, thank you for being online. We will reconvene for our final presentation in about 20 minutes at 4:30 p.m. Eastern Time for the Materials Protection and Accountancy Program. Please tune in then. Thanks.